Hello everyone, welcome for this today's session. In this session, we are going to discuss about the method of joints for the truss problem solving. Already we have discussed what is a truss, what is a frame, what are the different types of frame, and statical determinate or determinate. What are the methods are available to analyze the truss or frames. Here, one of the method is called the method of joints, and in this class we are going to solve one problem, and the methods we are going to discuss. So here the truss is given, and the main aim is to find the member forces in the given truss. So you just look on this truss. We have AE, ED, DC, as well as CB, and from B it is B to E, as well as from C to E. So number of members 1, 2, then 3, 4, 5, 6. So totally number of members 6 members are available. Then what are the number of joints? 1, 2, 3, 4, 5. Okay, so totally 5 joints are available. So 2j minus 3, it is equal to 7. And what are the number of members? So 1, 2, 3, 4, 5, 6. Okay, and another load is acting on at external load is acting on at joint D, that is 600 Newton, and 900 Newton at joint C. And the distance is given. The vertical distance from C to D is 4 meter, C to B is 4 meter, and the horizontal distance from A to B is given as 6 meter. These distances are given to find out the angle of inclination for the given member between two members. For the purpose only it is given. So we have to analyze the mathematical analysis approach. We have to use it for finding the member forces. First we look on which joint we are going to take. So we don't know about the reaction at A and RA and RB. These are the support reactions, but these are all unknown values. Let's start with joint D, REC or E. I already told you that whenever you are going to select a particular joint, there should be unknowns, not more than two unknowns. If more than two unknowns, we cannot able to find the unknown values because we are having only the sum of all vertical forces are equal to 0, sum of all horizontal forces are equal to 0, statically equilibrium equation. So two equations, two unknowns can be found out. For that purpose, we are going to identify. So now we are going to take joint D. Here we are having DE and DC. Two members are available, and this is 600 Newton is external loading. So only two unknowns. Okay. So for that, how we can draw the free body diagram? Here you can go for free body diagram. I will show you. So initially we are having directly at point D 600 Newton towards left. Okay, and DE and DC. DC is directly a perpendicular member, and this is an inclined member. Okay, and how to find the angle of inclination? That is the uh, you just take this right angle triangle. Okay, this right angle triangle, this distance we cannot know, but this distance we know. Okay, and this is also unknown. So only one known value, with one known value we can find the angle of inclination in a right angle triangle. So you take this whole right angle triangle ADB here, because this distance, horizontal distance is known, and this is totally it is 8 meter, this is 6 meter. Now we can find this theta. So opposite value, this is adjacent, opposite by adjacent is nothing but tan theta. So tan theta equal to 6 by 8. So whatever the theta, tan inverse of 6 by 8, that is equal to 36.87. Now let's come with the free body diagram. What are the other things will come? Because we are having another thing is DE as well as DC. Okay, here we are having DE and DC. Okay, DC goes towards left side, and DE let's take towards this side. Okay, I know that the angle of inclination for this DE, because this is purely vertical. Okay, so with respect to vertical axis only we know the angle. So 36.87. So if you move this side, this angle will be also 36.87. So these things here, only two unknowns. This is known value. So statically equilibrium equation you can use it first of all. And you take all horizontal forces are equal to 0 with the sign convention taking towards right is positive. So this is 600 towards left, that is minus 600, and this goes towards right side only for horizontal, that is cos theta, but it not come cos theta because it comes as sin theta, because the angle is not with respect to x-axis, it is with respect to y-axis only, that 36.87. So horizontal component can be resolved into FDE sine theta. Like that you can put. Otherwise, if you are taking cos, that will be wrong because the angle of inclination is with respect to y-axis. Okay, so accordingly, just substitute, get the value FDE, that is equal to 1000 Newton. Here it is compressively we are given. So this is compressive force. Then we can use another statically equilibrium equation, that is sum of all vertical forces are equal to 0. Here we are having 1 and 2. So FDC towards downward force, that is negative value. So minus FDC. Then this is FDE cos 36.87 and it goes towards upward direction, that is positive. Okay, then you will get the value of, because this FDC already we have get FD equal to 1000 Newton already. You just substitute here FDC, we will get it 800 Newton. That is towards path, that is positive value. Is a tensile force. Next, we will go to take another joint C. If you go for joint E, this one already found out, but this is unknown, this is unknown, this is unknown. Three unknowns are there, so you should not take joint E. So another chance we can go for this joint C. At joint C you have this is known value 800 Newton, and this CB is unknown, this C is unknown. Okay, so only two unknowns only. So just draw a free body diagram. So FCE and F, this is 900 Newton, FCB. Like that you can take. Then find the statically, that is use the statically equilibrium equation, get the value of horizontal component FCE value, that is 900 Newton. This is towards compressive on the C point, compressive force. And all sum of all vertical forces equal to 0. So you have FCB towards downward force, that is negative value, and you have upward force. So that is something but opposite both are equal. Okay, but then FCB is equal to 800 Newton, that is tensile force. Then what about another one? We are going moving on to the another joint taking as E. Now this is known value. Okay, from EC is known value, ED known value. Okay, here, but EB is there, EA is there. So these two members are unknown to be found out. How to find these two members? Okay, so this angle of inclination we already found that 36.87. Okay, so from joint C I can draw the free body diagram. 900, okay, 900 Newton, and this is FCD, that value we already found out. Is FCB, this value already found out value, and FCE. Sorry, actually we are taking everything joint E only. Okay, so from this point we are taking, from this point we are taking. Okay, the free body diagram. Just see, like that it comes. Okay, at E we are having AE or EA and DE, there is 1000 Newton found out value, and CE this is 900 Newton, and EB is an unknown value, EA is an unknown value. Okay, now I want to find the angle of inclination. Okay, but initially it is not available. We have to find how to find this angle of inclination. Only this angle no, but this angle is not known value. But we know the right angle triangle. If you take the full right angle triangle, it is 8 meter, this is 6 meter, okay, and this is 36.87 degree, okay. Then what about this angle? This angle is nothing but, if you take full right angle, ADB, so this angle can be found out, okay. This is nothing but this sin theta equals sorry, tan theta is equal to opposite by adjacent, 8 by 6. If you are putting 8 by 6, that is equal to 53.13 or 8 by 6 here, okay. So this angle we can found out. Now I'm need of the angle here. Here is given us 53.3. How it comes? You know that this either shape, okay, that will be equal to 53.13. This angle, okay. If it is 53.3, it is also 53.3. Then this will be how much? Whether both are equal or not. Okay, this angle and this angle will be equal. So this is 53.13, and whether it is also 53.13, how it comes? We know that this is 4 meter, it is also 4 meter, so equally, okay, distributed. So you just draw the line, it will be a bisect by this bisecting, so equal angle will be. So 53.13, here also 53.13. Now the angle of inclination directly associated with the members with E, everything we found out is 53.13 degree, okay. Now let's go for the free body diagram. All the values we have known that here, free body diagram, okay. Only unknown is FEA and FEB. You take the horizontal forces, sigma Fx equal to 0 as well as sigma Fy equal to 0. You will get directly, you will not get, because all are here, all three forces are inclined forces. Only one is purely horizontal. So you will get two equation from this, okay. This is when you are taking all the horizontal forces equal to 0, sum of all horizontal forces equal to 0, sum of all vertical forces equal to 0. Two equations are coming, then you just solve it. You simplify, you will get the value of FEA and FEB. Okay, 1750 Newton compressive force, 750 Newton tensile force. So from that, we found this one and this one. When you have taken D, when you have taken E, you this one and this one found out. This one also found out. So all the member forces have been found out with the values of 1000 Newton, 800 Newton, 900 Newton, this 800 Newton, 1750 Newton, 750 Newton. So the nature of forces are given as compressive, tensile, compressive, tensile, compressive, tensile. So based on the free body diagram itself, how we have drawn the uh, member forces, the arrow mark towards the joint is compressed or outward the joint, that is taken as tensile. Okay, if you take a tensile, and the positive value becomes tensile force. If you take an compressive force, the positive value comes compressive force, compression values. Okay, if you take a tensile but you are getting the values negative, then there will be a change in direction. That is called a compressive force always. Okay, so that's all in this given truss. By using method of joints, we have solved a problem to find the member forces. We will have another session with a different topic in the first unit. Thank you all.